Hello students, welcome to my class. Today we are going to discuss few questions related to D and F block elements and for NEET exam preparation. So friends, let's start the question answer round. Now my first question is, look at what I'm telling. Which of the following ions of D block has D0 configuration and D subcell is empty? Now tell me here D0 configuration. If I talk about Mn, look at, I'm giving you a detailed solution, check it out. Here Mn, the oxidation state is +7. Clear? What does it mean? That is, as we people know, the atomic number of Mn is 25. If it loses 7 electrons, the general electronic configuration, that is outermost 3d5-4s2. If it is in a +7 oxidation state, that will, what will happen? It will loses all the 7 electron and the electronic configuration in this case is 3d0. Yes sir. Now if I talk about chromium, as we know chromium has atomic number 24. Yes sir. What is the electronic configuration? That is 3d5-4s1. Yes sir. Now it is in a +6 oxidation state, that is +6 oxidation state. Now what will happen friend? That it will loses all its electron, 6 electron, that is the electronic configuration here is 3d0. If I talk about titanium, as we people know the oxidation atomic number of titanium is 22 and what is the electronic configuration? That is 3d2-4s2, outermost electronic configuration. Clear? And here titanium is in +4 oxidation state. If titanium is in +4 oxidation state, then what will happen? That is the general electronic configuration, like after losing 4 electron, that is after gaining the +4 oxidation state is 3d0. Now if I talk about, now check out the option. D0 all have this one and this one all have D0 electronic configuration. So we people can say for this question, sir, what is the option? That is D, all of this. D is the correct option. Now I'm going to rub this part. Now friend, let's move to the next question. Check out the next question. This is completely theoretical question. Which of the following group of D block does not contain transition element? As I told you earlier, there is 4 series of D, that is 3D series. The last element is Zn. It has completely filled D subcell, D0. If I talk about 4D, that is CD. If I talk about 5D series, Hg. Clear? If I talk about 6D series, that is Cn. We do not need to consider because these are radioactive element. If I talk about Zn, CD and Hg, here 3D10, here 4D10 and here is 5D10. Clear friend? All have completely filled D subcell. If they have completely filled D subcell, then they are not treated as transition metal. They are treated as, I'm moving here, only D block element. Yes sir, they are treated as D block element and they belongs to, that is the electronic configuration 4s2 3d10. Here is 5s2 4d10, here is 6s2 5d10. So group number in this case we can say that is group is 12. So 12 group does not contain transition element, they contain D block element. So the option, check it out, which of the following group of D block does not contain transition element? So the answer is group 12. Clear? Now I'm going to rub this part friend and will be discuss the next question. Wait for a moment. Now Let's move. Question number 3. Which oxide of first transition series is not amphoteric in nature? This is completely GK/GS type question. As we know, ZnO, V2O5, Cr2O3 all are amphoteric nature. What do you mean by amphoteric? As I discussed earlier, that is acidic and basic, both properties, then they are amphoteric in nature. As I told you earlier, if it react with acid, it can forms a compound. If it react with base, it also forms a compound. Similar case of vanadium, similar case of chromium. But if I talk about scandium, this is not amphoteric in nature. So for this, D is the correct explanation. This is completely theory based, no more explanation is required. Why and why not? Clear, friend? Now let's move to the next question. What I'm telling, listen carefully. Look at which of the following arrangement does not represent the correct order of the property against it. Look at what is first option, stability in aqueous solution. If I talk about cobalt, Fe3 plus, that is if we moving from cobalt is 27 atomic number, iron atomic number is 26, chromium the atomic number is 24, and for scandium the atomic number is 21. Yes sir. What is the general electronic configuration? That is cobalt 3 plus, that is loses 3 electron. Here is Fe3 plus, it loses 3 electron. Chromium 3 plus, it loses 3 electron, and scandium 3 plus. In case of scandium 3 plus, the electronic configuration finally 3d0. In case of chromium 3 plus, as we know, chromium has electronic configuration 3d5 4s1. So if it loses 3 electron, then what will happen? That is the 3d3. If I talk about iron has electronic configuration, tell me, that is 4s2 3d6. If it loses the 3 electron, then what will happen? The electronic configuration is final 3d4. If I talk about cobalt, what is the electronic configuration? 3d7 4s2. If it loses 3 electron, then what will happen? It will give you 3d5. The electronic configuration is 3d5 outermost. Now look at what question has stability in aqueous solution. As we know, if we move, that is, or you can say if we move up, that is from scandium to cobalt, then what will happen? In this case, stability in aqueous solution increases. So the order is scandium 3 plus, chromium 3 plus, Fe3 plus, and cobalt 3 plus. This is the actual order. Now according to the question, we can arrange like this: cobalt 3 plus, Fe3 plus, yes sir, chromium 3 plus, then scandium 3 plus. This is the correct. So first option is the correct order. Now second one is number of oxidation state. As I all know, if we move from scandium to Mn, scandium, titanium, vanadium, chromium, and Mn. Mn has maximum oxidation state tendency +7. So this is also a correct option. Now if I talk about the paramagnetic behavior, as we know, paramagnetic behavior depends upon the number of unpaired electron. Now check out the number of unpaired electron in this case, and what will happen, tell me. Look at vanadium. As we know, vanadium has atomic number 23. Yes sir. Now what is the electronic configuration? As we know, the general electronic configuration of vanadium is 3d34s2. Now if it is 2 plus oxidation state, then it will lose this electron, and the electronic configuration is 3d3. So in this case, what is number of unpaired electron? Number of unpaired electron is 3. Now if I talk about chromium, wait for a moment, chromium 2 plus, check it out what will happen. Chromium has atomic number 24. What is the electronic configuration of chromium? So 3d5 4s1. Now 2 plus oxidation state, then this will lose 1 electron from here and 1 electron from here. The electronic configuration is, sir, 3d4. That is, in this case, number of unpaired electron is equal to 4. Number of unpaired electron is equal to 4. Now check it out. The next one, that is Mn2 plus. Wait for a moment. Before, number of unpaired electron is equal to 4. Now what I am telling, that is Mn2 plus. As we know, Mn has atomic number 25, general electronic configuration 3d5 4s2. What will happen? It will lose this electron because 2 oxidation state. So Mn2 plus has outermost oxidation state, it is 3d5. In 3d5, tell me number of unpaired electron is equal to 5. Okay, sir. Now if I talk about Fe2 plus, as we know, Fe2 plus has electronic configuration 3d6 4s2. Clear? 3d6 and 4s2. So if it is in a +2 oxidation state, then loses 1 electron, that is the 3d6. Now in 3d6, tell me the number of unpaired electron. Sir, is very simple. Number of unpaired electron is equal to 4. Now look at, in case of chromium and iron, chromium 2 plus and Fe2 plus has equal number of unpaired electron. If equal number of unpaired electron, then paramagnetic behavior will remain same. But here look at, chromium has less paramagnetic behavior in comparison to Fe. So this is not a correct arrangement. So this one is wrong. Now next check. If I talk about nickel, I am moving here. Atomic number 28, cobalt atomic number 27, iron atomic number 26 and Mn atomic number 25. That is, if we move from lower atomic number to from higher to lower atomic number, then definitely this is the correct order. Ni2 plus, CO2 plus, Fe2 plus and Mn2 plus. Clear? So this is definitely a correct arrangement. As I discussed, the order of the size. Clear? Here is the anomalous behavior from scandium to Mn, then from Mn to Zn. 2 barriers are there. Do you remember this? The concept, it is very simple. So in this case, which option is correct? That is, which is not correctly matched? Sir, that is the C option. So by looking at this, we people can say C is the correct option for this question. Clear? Now wait for a moment, friend. I am going to rub this part and we'll discuss the next part of the question. Now the next one, question number 5. This is completely theory based. What the questions tells, which of the following contains Fe as well as Cr? Wolframite, chromite. We know formula of chromite is CrO into Fe2O3. Remember this, what I am telling. The formula of chromite is CrOFe2O3. In chromite, there is chromium as well as iron. So the answer is B, that is chromite. Clear? Now let's move to the next question. What will happen in this case? Check it out. The next question is, look at. This is one of the best question. Metal of first row of D block which have positive electron gain enthalpy. That is delta Eg. Electron gain enthalpy, or it can be written like this, is positive. Generally, electron gain enthalpy comes negative because the process is exothermic. That is the general case. But according to the question here is, which have positive electron gain enthalpy. So how to proceed? Tell me how to check. Look at, if I talk about chromium, atomic number 24, yes sir, it has general electronic configuration 3d5 4s1. Clear? If I talk about Mn, clear to you? Second one, atomic number 25, it can be written like this, 3d5 4s2. Yes sir. If I talk about iron, atomic number is 26. It can be written like this, 3d6 4s2. Yes. If I talk about zinc, Zn, atomic number is 30. It can be written like this, 3d10 4s2. Now, in which case there is a positive electron gain enthalpy. As we know, if there is a half-filled subcell or full-filled, then they are more stable. And if they are more stable, then definitely there is a involvement of energy, not liberation of energy, not evolution of energy. Look at, if I talk about Mn, 3d5 half-filled. If I talk about Zn, 3d10 fulfilled. So in case of Mn and Zn, they will have high value of electron gain enthalpy. Where is Mn? This one and this one. And check out the option 1 and 2, not 1 and 2, 2 and 4, 2 and 4, Mn and Zn. So for this question, B is the correct option. Clear? Now friend, wait for a moment. Now let's move to the next section of the question. What will happen? Check it out. The next question is question number 7. Which of the following is not the isotopic symbol of uranium? Now tell me, what is the symbol of uranium? This is very simple question, but frequently asked question. As we know, the symbol of uranium is U. It has atomic number 92 and it exists in two isotopic form, that is 92 here also. Now we all know that is here the one isotopes has atomic mass number 235, then other has mass number 238. Clear? What is isotopes? We people know isotopes are the pair having equal atomic number. Look at here, wait for a moment. Having equal atomic number and different mass number. Clear? So in this case, this is the symbol of uranium, that is X23592, then X92 238. But so this one is the correct symbol according to the question, which is not the isotopic symbol. So if I talk about X9235, this is not the correct symbol of uranium. 90 is the atomic number of thorium, not uranium. So for this case, we can say Sir, which is the correct option. So C is the correct option, that is it is not the isotopic symbol of uranium. Clear friend? Now wait for a moment, I am going to rub this part and we'll discuss the next section of the question. Now let's move. What I'm telling, listen carefully. Question number 8. This is a question. Now tell me, select the correct matching. Monazite, pitch blende and sapphirite. Now tell me, is this monazite, metal is thorium, and pitch blende, that is uranium? Yes. If I write the formula, that is U3O8. Clear? And this one is THO2 and this one is ZnS, zinc sulfide. Now look at in monazite, that is thorium. Here look at uranium. Here look at zinc. So this one are correctly matched. So we can say for this D is the correct option. What I'm telling, for this they are completely matched. And now we can say in this compound, first one, it contains thorium, it contains uranium, it contains zinc. So for this D is the correct option. Now I'm going to rub this part friend and we'll discuss the next question. Wait for a moment, give me few seconds so that we can easily solve such kind of questions. That is question number 9. Which of the following electronic configuration of lanthanide is related to the formation of +2 ion? Now tell me, it's your turn, you have to solve this question. It is one of the simplest question. You can easily reply this question. Which of the following electronic configuration of lanthanide is related to the formation of +2 ion? Lanthanide, what I'm telling friend, lanthanide, tell me what will happen. This one, no, +2 oxidation state. Xenon atomic number, that is the inert gas 54, that is xenon, clear, 4F7 and 6S2. This is the correct explanation. So for this question it's very simple. Lanthanide +2 ion, that is the +2 oxidation state. Generally in case of lanthanide, a general electronic configuration is +2, sometimes +3, and extreme case there may be +4 oxidation state. But for +2 oxidation state, C is the correct option. Clear? Now I'm going to rub this part and we'll discuss the next one. Wait. The next question is, select pair in which size of element is not almost identical. Now tell me what will happen. This is the question from my side to you. Select pair in which the size of the element is not almost identical. As we know, if I talk about zirconium and hafnium contraction, lanthanide contraction, then in this case they have equal size. Neodymium and Ta also has equal size. In case of molybdenum and tungsten, they have also have same size. But if I talk about titanium and zirconium, they have, that is titanium here and zirconium here. In this case, in case of titanium, there is 3D, here is 4D. The down the group from 3D to 4D, size increases. So in pair in which the size of the element is not almost identical, that is the D option. Clear? So I think now you can easily solve such kind of question. This chapter, again I am telling, is a completely theory based question. You can easily solve such kind of question. So my friend, that is, now we review the question again and we'll find it out what was the correct option. Now for question number 1, tell me what was the correct option. Sir, all of these. That A has, question number 1 has D option. Now check out once again, which of the following group of D block does not contain transition element? Sir, group 12, that is A option. Now, which oxide of first transition series is not amphoteric? As I told you earlier, V2O5, ZNO, Cr2O3, all are amphoteric in nature, but Sc2O3, scandium oxide, is not amphoteric in nature. D option. Question number 4, as I told you, first option is correctly matched, second option is correctly matched, but the third option is not correctly matched because paramagnetic depends on the number of unpaired electrons. So C is the correct option. Now for question number 5, which of the following contain Fe as well as iron as well as chromium? As I told you, chromite, FeO into Cr2O3, in which iron and chromium contains, which contains iron and chromium. Now let's move to the question number 6. As I told you, if half filled and full filled, high stability, in this case they have positive value of electron gain enthalpy, that is Mn and Zn. One more thing I am going to mention here, chromium. Chromium has normal oxidation state, not 3d5, 3d4, 4s2. Due to gaining the stability, that is 3d5, 4s1. So we will not consider chromium. You can arise a question. So I am repeating, chromium 3d4, 4s2 for gaining stability is modified its electronic configuration from 3d4 to 3d5, 4s1. So the best one, that is Mn and Zn. Now for question number 7, which is not a correct symbol, the C is the correct answer for this question. Question number 8, that is they all are equally matched, so all of the above are correct. D is the correct option. Now question number 9, as I told you, C is the correct option. Xenon 4F7 6S2. For question number 10, select pair in which the size of the element is not almost identical. Titanium and zirconium. Clear to you? So friend, I think now you can easily solve such kind of question. Time has come, time to say bye bye. Thank you so much.